Previously on a digital journey, we looked at how to unmake a mess of things. We found out the limitations of video on WebEx. We found out that budget shouldn't be a problem. Means that if a budget doesn't exist, then it isn't a problem. And there is no limit to what you can do with PowerPoint. Given enough time and not enough sleep, but I digress. We met a hardworking engineer named B, and B had a problem. B was faced with a massive internal language barrier. The sales guy didn't speak designer, who didn't speak customer, who spoke of a need to just get his machine built. B realized that if she could just match all of these different needs with a basic list of designs that she had already made, she could take all the little parts and pieces from the jobs in the past and match them with the customer's needs in the present. Later, we found out that this was called cogeneer, meaning collaborative engineering, known as eBuild, part of ePulse. This is completely straightforward. Hey, ask your salesperson. Hello, everyone, and welcome to the fourth episode of A Digital Journey. It is a 12-part series learning how to do stuff a little faster, hopefully a little better, and with less effort. I will be your moderator, Andrew Fortenberry. After the episode, we will have a Q&A session. So during the episode, please post any chats into the chat bar, and I will be sure to answer them. Please leave us a note on how we are doing, questions, comments, and if so, even any nasty remarks. Today, we are going to talk about PLCs. For those of you who do not like acronyms, we are going to talk about programmable logic controllers, the sturdy little boxes that bring all of our wonderful designs to life. For the past 50 years, these computers have been the brains in some form or another behind all industrial processes. When you start to move your control design from schematic, loop diagrams, to PLC, you are immediately faced with a question. How? And now Sergio will answer.
We're going to start with the assumption that most sane people make logical decisions, or at least intend to. We assume that any design will involve many different disciplines, mechanical, electrical, and the catch-all controls. Eventually, decisions made in one discipline will affect the decisions made in another. Ideally, the design process would involve a collaborative approach and spiraling towards an effective, efficient design. However, in practice, resources and time run short. Competitive interests disrupt the processes and things will spiral, however, not always in control. Of particular interest is the crossover point between the schematics and the PLC. Again, we make some assumptions. We assume that we know the capabilities of the controller. We assume that we have clarified all of the interfaces. We have the right input-output cards, memory, scan time, all of the hardware, and most importantly, and why it is at the end of the list, or documentation, and which I/O address goes to which device. How do we organize our tags? Regardless if we use ordinary ladder logic programming or automatically generated code derived from a multi-physics model-based simulator. Ultimately, we need some sort of intermediate program to transfer data from the schematics to the PLC code. A traditional method would be to use simple text files or Excel spreadsheets and cross-check each device one by one against the data in the PLC programming tool. This is a time-consuming task and prone to errors as it relies on the dexterity and concentration of the designer/operator working the programming tool. There are, of course, methods to automate some of these steps. Most CAD tools can export a simple text file or spreadsheet, and most PLC development environments can import that very same file. However, if changes to one or more sides of the design are made, the designer is required to maintain and organize these individual files. Again, a set of revision control tools are needed, which again involve another layer of maintenance. If there are more people involved, there are more chances for errors. simple transcripts errors which have nothing to do with the actual execution of the PLC code and will not be caught by the PLC compiler will nevertheless be transferred to the controller, with less than desirable results. Administrative oversight, such as requiring simulation and multiple design checks, can solve some of these problems, but the amount of effort required to check whether or not a list has been moved from one machine to another begs the question, is there a simpler, safer way? Thank you. Thank you, everyone. Too kind, too kind. Be sure to tip your waitress at the end. Hopefully you enjoy that as much as we enjoy doing them and putting these together for you guys in a more comprehensive way, probably, maybe not. But anyway, so the software demo at hand. What are we talking about? PLC. So let's dive right into it. We, as we proceeded with our episodes, we saw all the different facets, all the different steps, and we derived from our project settings that when we were doing our pre-planning phase and we were doing our schematic generation and whatnot, we ended up with a pre-calculation of the amount of IOs that we need. So since the topic of the day is PLCs, this is the what we're going to kind of tackle into and how we're going to blend in this information together. So, of course, knowing full well how we proceed into all our different facets of our engineering processes, we know we have certain schematics assigned to our pre-planning objects. And as we saw in previous episodes, we can insert these. And as we are inserting these different objects into our schematic environment, information is being produced. Now, obviously, the benefits of all this is that ease of functionality and also the fact that we can also benefit from a drag and drop and ease of use tools. Now, of course, as we're using and building up our schematics, we're putting PLC information inside the schematics. And that PLC information will be found inside our navigator, depending on the IO. And as we saw previously also, even from this particular environment, we can also create different PLC overview sheets that will give us a lot of detailed information. And what we're going to be end up doing is we'll basically start to use other tools to be able to merge that. So just as we saw in the animation previously, we want to try to avoid that separation between two disciplines. What I have here is an environment, which is basically the Studios 5000 Architect. We do have other applications that we can communicate with. So we'll look into those eventually in some other episodes. But the benefit here, of course, is to have import and export capabilities. Now, based on our design, we saw that from the pre-calculation of our pre-planning environment with our report that we done, we have a small, simple project that we need 10 outputs and 13 inputs. So basically, an A4 rack would do me justice here. So if I drop in an A4 rack and I go ahead and grab the controller, dump it in. Again, the benefit of when we're starting to work with easy and ease of use tools, the benefits start to unfold. Of course, the interaction and the ease of use functionality greatly help. Of course, there is some you have to know how to use these tools eventually. But of course, this is like any other application that you need, and especially with the progression that the environments that we're working with are going and expanding, and all the changes, and especially with the current situations, these are things that we have to take into consideration. How do we make these things faster? So having that done, having this information integrated in my environment, what I'm going to do is I'm going to choose the export functionality, and from here I'll be able to export my my PLC file. So I can create a new one just so, in case we have those people that say it's pre-cut. So let me do an RAF demo July. That'll be my file. And of course it's exported. And as you notice, what I exported is an AML file. We discussed the AML in our podcast, so be sure to tag along, follow us on the podcast channel, and you'll be able to benefit from all the cool information that's out there. So AML, being the tool of the weapon of choice, of course, has a lot of capabilities. We're going to grab that file and we're going to import it into our project. So here, choosing the import data, I'm going to grab that AML file. So I'm going to choose the one I just created, bring that guy in. And basically what the system will do is it brought 4 devices, 1 CPU, and I'm good to go. So these devices are here, but they're generic. They're not necessarily correlated with my design. Of course, these outputs these inputs that I have here are brought in based on the macro tools that I'm using. And of course, they have generic information themselves. So here we have pin 1, 1, 1, and so on and so forth. So there's no real correlation. I'm going to grab that information and blend those two together. So grabbing the file or the information that was brought in from the PLC tool, and I'm just going to blend that in. So to do so, I'm going to grab here a little filter to start with my inputs first, grab all my inputs, and I'm going to choose here PLCs, and I'm going to say use connection point blockwise. And from here, what I'm going to do is I'm going to assign it to my digital IO card. And I know I need 13 pins or 13 points. So I'm going to say 8 here, 1, 2, 3, 5. So that's going to be my 13. They line up. And now you'll notice that my connection points and all the data that was exported out or brought into my EPLAN tool will now inherit the information that I had in my pre-planning environment. So as soon as I hit OK, now you'll see pin 1, 2, 3, and I have all the information and description all aligned. I can proceed now to do the outputs. So very simple steps. The benefit here, again, is the capabilities of having a tool that can give you an ease of use workflow, regardless of the fact that maybe back in the day you used to do things a certain way. That's 5, 6, 7, 8, 9, 10. Yes, I had to use my fingers when I was in school counting and doing math. But yeah, basically having these tools that will, once you grasp your head around the concepts, will give you great benefit in the long run. So having that done and integrated all my information, if I go here to my rack-oriented view, I have here my my project, my station, my rack, and all the different tools and hardware. And here, basically, I have some information that correlates in with it. The idea, again, is the principle of being able to have these two tools interact with each other. So it's not a direct communication per se, if you will, but the idea really is the concept of being able to grab this information and being able to manipulate it in 2 instances by means of import and export, as opposed to use a third party or a script or an Excel spreadsheet with macros and things. All these tools are great. They all work. There's nothing wrong with any of them. It's just that there are certain benefits. Once you have your concept wrapped around, you can do these kind of things. So hopefully this kind of enlightens you into this topic. And let's go back here, and here we go. Right, so we'll move into the Q&A session here now.
Sergio, thank you so much. So the first question that we have is, PLCs can EPLAN handle?
How many different PLCs? Okay, so I guess the question is how many PLC hardware types or software types, I guess. Maybe I'm phrasing myself wrong. So what you can do is inside the import or export application under the PLC configuration program types, these are all the different configurations available. Of course, as you can see, we got Beckhoff, BNR, ABB, Mitsubishi's, and so on and so forth. A lot of these are still in process of being reworked and revamped. We had some, I believe, if I'm not mistaken, Mitsubishi did an update and things were working great. Mitsubishi did an update and now it wasn't working. We have similar cases with Rockwell. They're also looking into their AML environment with the new formats. So there's still a little bit of work that's being done. Siemens also, with their TIA portal versions. So they all work, but they're still getting revamped. So if you're out there, if you're seeing certain things that are not maybe working out, feel free to contact your support. The support team will make sure to get a hold of the PLC experts in Germany and see what's up. But all in all, the tool seemed to be working very seamlessly. We had no issues with the Studios 5000 tool just as yet. But yeah, these are pretty much all of the configuration capabilities that we have.
Excellent. Thank you. And next question. We saw how to move data from schematics to the PLC. Is there a way to move data from the PLC to the schematic?
Yes, of course. So there's the schematics to the PLCs, but there's also a PLC information that we can bring in, whether you're inserting a device, of course, whether it be a PLC device, and you can bring it into the schematics. Also, the benefits of being able to benefit from all the different functionalities, as you saw me do earlier. If I grab a overview sheet from the PLC, what I can do is from the schematic point of view, I can grab that PLC IO card, drag it into an overview sheet, and I will have the overview information of that sheet. Of course, I'll have here all the representation data that's coming from the schematics into the PLC environment, and so on and so forth. So yes, from the PLC to the schematics, we can import, and from the schematics to the PLC, we can output.
Excellent. We have another question. Can you generate blockwise macros via PLC to generate schematics?
Blockwise macros. Okay. I believe, and correct me if I'm wrong, we have the bitwise, which is represented here. And of course, this is probably not a technique that a lot of people are familiar with. And the benefits of having this type of technique is the fact that we can just show on the schematics the IO points that we require. And as you just saw me do here in the PLC overview, I can have the whole card overview in a form of a report that reflects what's actually happening in the schematics. But of course, inside the schematic environment, it all depends on the macros that you're using that are associated to your parts. In the part data for all these objects here, if I look at the digital input card and I look at the properties in the part information, you can associate a schematic macro that you will be using in order to use the auto generation function. So here, this macro will be utilized to create. So this is an overview, but you do have multiple representations for this particular macro. So you could have a multi-line schematic, a single line, an overview, a whole bunch of them. So these will be the ones represented and used in the auto generation. So it's up to you to fine tune it. We do have courses that are being put together on these, and we also have macros. The data portal has some macros available. There has been a lot of feedback about the data portal parts. We've created a data portal standard. We've sent it out to all the manufacturers. They're starting to abide by those regulations. So hopefully, crossing our fingers, it's up to them to create and put these things together better, and we should be getting benefits from using the new macro information and be able to work with all these different features.
Excellent, excellent. Next question. If I want to reorganize all of my PLC tags in EPLAN, how would I do that?
Yeah, so there are tools in place where under PLC, you can readdress. You can choose the address and assignment list also, which is very beneficial, which kind of gives us a similar representation of our Excel spreadsheet that we're accustomed to using. And of course, we do have capabilities here of readdressing, removing around. We do have capabilities of also exporting out and re-importing in using our edit externally features, which are also beneficial. So depending on the level of knowledge that you have using EPLAN, there are multiple facets or multiple ways of doing these things. So this could be something, there's a whole bunch of ways. We do have, again, we're working really on e-learning tools. So hopefully, especially for the North American crowd who is really busy and is overworked. So we're trying to get these things out. There are also coaching services. So one key factor could be for the users out there who want more in-depth coaching services, just like if you would go to a gym, you paid the membership, you're working out, but you want to have that extra oomph, you get yourself a coach who's going to give you all the tricks and tips, same concept. So let your sales rep know that might be something you're interested in.
Thank you, Sergio. So we have a couple more questions. What information do you have to put in to the parts in EPLAN to be able to transfer information, such as function text to Studio 5000?
Right. The function text is technically the information that you get from the IO point. Now, the function text property, or this basically would be the property, the description property, and the symbolic property. There are certain attributes. A lot of people have this misconception that it's just a magic wand. You purchase the license of EPLAN, and you can just, while you're sipping your coffee, EPLAN is doing everything for you, which is not the case, and that's with any tool out there. There are certain fields and properties that need to be populated. We do have a lot of, we have some tech tips online. Rockwell created a white paper that's online that you can also get your hands on, which basically really is a deep dive between the integration between EPLAN and the Rockwell tool, as well as other applications out there. I know there are certain documentation in the EPLAN information portal. If you Google that, you'll have some tech tips there as well that'll explain to you what fields need to be populated. So in this particular case here, the function text will be converted over to the description. The symbolic address will also be brought into the PLC program in the proper fields. Just an example of need to know information. One of these is one that I actually personally had to tackle myself. The symbolic address cannot take any spaces. So in the transfer of data from EPLAN to, and apparently it's with other tools that I found out, there's no spaces available. So when you use an underscore, it gives you that effect. So these are knowledge-based information that, you can ask us in support, you can ask us, and even with the coaching service, we can look at this more in depth.
Sorry to do this to you, Andrew, but we had like 2 more questions come in right as we started the outro. Great job, everybody. First one is, in your demo, you use Studio Architect. Is it also available in Pro Panel?
So there are packages available in Pro Panel. You would add the add-on of the PLC into your Pro Panel environment if it's something that you require. So yes, it's available.
That's our time for this episode. Hope you enjoy it. Please leave us a note on how we are doing. You can drop it in the chat. Also, take the survey that pops up as you leave. If you're not following us on LinkedIn, please search EPLAN USA, click the follow button. Feel free to share any information that you like. If you're sharing anything regarding the episode, do hashtag EPLAN Digital Journey 104. And now some shameless plugs. If you have enjoyed anything that you have seen in today's episode and would like to know more, check out our step-by-step how-to videos on the EPLAN Learning site. The site is posted in the chat. And also, if you want to learn more information about ePulse, you can go to epulse.com, and that's EPULSE.com. You'll be able to learn about eView, eBuild, the EPLAN data portal, the EPLAN platform, and also Sergio had mentioned about the podcast. So it's a brand new podcast that Sergio and myself are doing. It's called Efficient Engineering, and you can search it by going to eplanusa.com/podcast. And that's about it from me. So thank you so much, everybody. And until next time, my name is Andrew Fortenberry, and we're signing out.